Hey Calculus AB, my name is Richard Merzoin, and in this video you will learn to calculate the area between two curves using different integral expressions. To start, you are given two equations. For this example, these are y equals 4 rad x and y equals 1/2 x squared. To determine exactly how much area you're trying to find, or in other words, to find the bounds of your integrals, set both equations equal to each other and find where they intersect. After all the math is completed, you will find that these two equations intersect at coordinate points 0, 0, and 4, 8. To set up the first integral, what you want to do is take the higher curve and subtract it by the smaller curve, as demonstrated by the three graphs. This will leave you with the area in between both curves, which is what you're looking for. Given that the x values of both intersection points are 0 and 4, these are your lower and upper bounds respectively. Inside the integral, you will place the equation that represents the higher curve first. In this case, that is 4 rad x. Next, subtract this by the lower curve, which is 1/2 x squared. Your final answer will be the integral from 0 to 4 of 4 rad x minus 1/2 x squared dx. Keep in mind, however, that although it is not present here, the subtraction will apply to all parts of the second equation of the lower curve, not only the first term. For the second integral, you will need to solve both equations for y rather than x, as we are now viewing the graphs from the side. After solving, you should be left with 1/16y squared equals x and radical 2y equals x. Whether or not the curve is on the negative or positive side does not matter, seeing as the area under the curve remains positive either way. As we view the curves from this perspective, the lower and upper bounds change. In this case, the bounds will be from 0 to 8, as shown here. When viewed at this angle, radical 2y is now the higher curve, and 1/16y squared is the lower curve. After completing the same steps as done before, subtracting the lower curve from the higher curve, you will be left with the integral from 0 to 8 of radical 2y minus 1/16y squared dy. And that's all there is. I hope that this has been helpful, and I'll see you in the next video.